Hello everyone, and welcome back to the garage. In this video, I'm going to show you how to dump, back up, and flash new game code on pinball machine and arcade game ROM chips. And I'm going to be using several pinball machines as examples. So let's get started. So this is the machine that I'm going to be using as kind of my main example. This is a Bally Strange Science from 1986, and it uses the Bally 6803 board set. So, to check the ROM version of what is on this machine right now, we have to push the button on the coin door. And this is one of those Bally machines that uses a keypad to go through the settings. So what we need to do is go to the self-testing category. So if we hit the letter A on the keypad, it'll go forward. And so we want to go to self-testing. And then once it gets to game ROM ID, you hit enter. So right there. So it's going through and showing the information about the two ROM chips on the CPU board. And so if you catch it fast enough, you can see it says Rev B. And we have U2 and U3. Those are the part numbers for the two ROM chips. So this machine has a revision B ROM set in it right now. But say you have a machine that uses a more well-known architecture like a Williams Pinbot. This uses a Williams System 11A board set. So to check the ROM information on one of these machines, you have to open the coin door, make sure that the auto/manual button is in the auto mode, and then press the advance button, and it should come right up to this screen here. And on the bottom right display, it shows the game number and the ROM revision. So Pinbot is game 549. That'll be different on a different machine. And this game has revision L2 ROMs in it. And this machine has multiple ROMs inside it, so you have to make sure that they all match. And so that is how you check that information on a Williams System 11 machine. This is a Gottlieb teed off from 1993. It is a Gottlieb System 3 machine. And if you want to check the ROM version on it, you can't actually do that through the software. You have to go behind the back glass and look at each of the ROM chips, because there will be a little sticker on each of them that shows what revision they are. And so with the back box open, you'll see that on a System 3 machine, there will be multiple ROMs spread out across almost all of the boards. So let's first take a look at the soundboard. You can see right there, those are two ROMs right there. Teed off and 736 is the game number. And newer revisions of System 3 ROMs will have a slash and a number after the game number. And so because these ROMs just say 736 and nothing else, these are the original revisions of the sound ROMs for the soundboard. You can see we have DROM1 and YROM1. And so that's how you identify the ROMs in one of these System 3 machines. And if we take a look at the speech board, you can see we have two ROMs on that as well, AROM1 and AROM2. And because they just say 736, those are the original revisions of the two AROMs. Over here we have the dot matrix display control board. And this one, you can see it says 736/1. That means this is revision 1. It's not just 736. It's not the original version. It's a revision made after that. And this chip is identified as DSP ROM, so display ROM. And if we take a look at the main CPU board, we have a ROM there, 736/1, so it's revision 1, and it is the GP ROM. And so in a System 3, that is how the ROMs are identified. YROM1, DROM1, AROM, GP ROM. There's different ROM identifiers, and it'll be like that on any type of machine you work on. It won't be exactly the same. Like on some machines, it may reference the socket number. Like on my Bally Strange Science, there was U2 and U3, because the sockets that those ROM chips are in are labeled U2 and U3. So it all depends on the machine you're working on, how you identify the ROMs and see what version they are. It's just different between different manufacturers. But for this video, I'm going to mainly focus on the strange science because I'm going to show you how to dump, backup, and reflash game code on your pre-existing ROM chips. So let's go behind the back box and I'll show you a little bit more about what you need to do. So for a Bally 6803 game that is before the Williams transition era, where Williams purchased Bally, the ROMs are going to be on the CPU board and on the soundboard. And different 6803 games have different soundboards, so if you're working on a 6803, you may have more or less sound ROMs than what is on this machine. And the very late 6803 games have a little adapter board that connect to a Williams System 11 soundboard. This is not one of those machines. So your ROMs may be completely different to this game. But all 6803 games use this board. This is the Bally 6803 control board, and it has two ROMs in sockets U2 and U3. So these are the two CPU board ROMs. And on the strange science, the soundboard is the TCS. That means Turbo Cheap Squeak. That is what Bally called this particular soundboard. And it has a single ROM, U7. That's what the socket number is. And so that is the sound ROM for this game. So the first order of business is to get the ROM chips out of the machine so that we can read them. And the way to do that is to use a chip puller. This here is a more common type of chip puller that you squeeze the chip and then pull it out. I don't really like to use those pullers because there's still a risk of bending the legs of the chip when you pull the chip out. So I'm going to be using this type of chip puller. This is my go-to. Well, all you have to do is just pull this back and those black plastic pieces will grab the chip and pull it straight out. So I'm going to be using that to pull out the ROMs. And before you pull the ROMs out, you want to make sure that you know the direction that the ROM chip is supposed to go in. And the way you tell is on the chip, there will be a notch on the middle of the chip on the side, and it'll either be up or down, or if it's mounted horizontally, it'll be either left or right. So make sure you remember that when you put the ROM chip back in. So I'm going to put this over the chip, and then if I squeeze it, it just pulls it right out, and there is the chip right there pulled out. None of the legs got bent. And so here is the sound ROM out of the strange science. And you can see on the top side of the chip, the little notch in the center. So make sure that you know what direction that notch goes in when you put the chip back into your board. Now I'll go ahead and pull out the U2 and U3 CPU ROMs. And so with those ROMs out, now I'm going to show you how to verify if your ROMs are good, and if they are good, how to dump them and back up their contents. And so here's where the process is going to become a little bit different between different types of machines and what board set you're working on. So the first thing you need to figure out is what type of ROMs you actually have. And there are two different types. There are PROMs, which are programmable ROMs, and there are EPROMs, which are erasable programmable ROMs. I happen to know that on a Bally 6803 game, at least for strange science, that these three chips are EPROMs. So that means you can erase the content inside the chips and program them again. If you just have a PROM, a programmable ROM, you can't erase the contents in the chips because they've already been programmed. So if you have a PROM, all you can do is read them out and back up the contents to your computer. You can't upgrade the code on the chips. But if you have EPROMs, then you can erase them and put updated code on the chips, like if you wanted to upgrade to a newer revision. And so if you have EPROMs, you don't actually have to buy new ROM chips in order to upgrade them. You just have to find the ROM images for the revision that you want to use in your machine. And so these three chips are EPROMs. And so now what we want to do is, once you figure that out, you need to figure out what kind of chips are these. So if we look at U2 and U3, you can see these are Texas Instruments chips, and they are part number 27C128JL. Both of these chips are. And the sound ROM is a 27256. These are actually pretty standard EPROMs, so what that allows you to do is hook these chips up to an EPROM programmer, and then you can read them out and back up their contents to your computer. And so this is the programmer I'm going to use, the XGQ Pro T48. And not all EPROM programmers are the same. Some of them can read chips that others can't. And so you just need to make sure that you have a programmer that is able to read the specific ROM chips that you have. And I verified that this programmer is able to read out these 3 chips. So we can go ahead and use this programmer, and I'll show you how to back up your ROMs. All right, I've opened up my EPROM programmer software on my computer, and the software is probably going to be different depending on what type of programmer you use, but you should be able to still follow along since we're just going to be doing some basic functions. So what I'm going to do now is I'm going to put the U2 ROM chip into my programmer. And so the U2 ROM chip is a 27C128. So what we need to do is set up the software to read that kind of chip. So for this software, I'm going to go to Select ICs, search and select ICs, and we're just going to type 27C128, and it shouldn't matter what type of brand that you use, but if your software is able to read the exact brand that you have, then you should just go with that. So my chip is a Texas Instruments chip, so that's right there, TI. And it is going to be a TMS 27C128 DIP28. That's the type of ROM chip. It's a 28-pin chip. So we're going to select that. And so now it's set up to read a TMS 27C128. And so what we're first going to do is read the chip. So I'll hit read, then I'll hit read again. You can see read finished, and so we got a good read out of the chip. I'm going to hit back. And so what we're seeing right here is the raw data that is stored inside that chip. And so you can see we actually have some strings in the chip data. You can see U2 Rev B. That's data stored inside the chip, and you can scroll through that, and you can see different data in the chip. We can actually read this out. So that's the data in the U2 ROM chip. And one thing you want to make sure, even though you may have gotten a good read out of the chip like this, it may not be a functional chip. And so the way you check that is by looking at the checksum right here. And so this is our checksum, 0x0017CBFF. And so what we're going to do is read the chip again. So we got a successful read. And you can see the checksum is exactly the same. So that means we got the same data out of the chip on the second read, because if the data was any different inside this chip, the checksum would be different. And so, for example, if your chip was marginal, if it was working only somewhat, and you still got a read out of it, but the checksum was different every time you read the chip, then you know your chip is bad. And so you want to read like 2 or 3 times just to make sure that that checksum is the same. And it's the same every time, so we know that we're getting good reads out of the chip. And so that is how you read out one of these ROMs. And so to save the contents to your computer, we're just going to hit save. The file format is going to be in a binary file in my case. And I'm going to choose just to save it on the desktop for now, just for simplicity's sake. And I'm going to name the file Strange Science. I'll just do STRSCI U2 Rev B. Since this is a revision B ROM, that's the code that's in this chip right now. So we're going to save it, and save as. File's been saved. And so we can see right here we have strange science u2 revb.bin. And so we have just dumped this ROM and saved its contents to the computer. And so we can use this file to rewrite this same code back to the chip. Now I'm going to go ahead and take that out and put U3 in the programmer. And so we're going to read it now, and because this is a different chip with different data in it, the checksum is going to be different. So we got a good read out of it. You can see there's a different checksum there, and you can see in the ASCII U3 Rev B. So, we got a good read out of the chip. Let's read it one more time just to make sure that the checksum stays the same, and it does. So we know this chip is good, and we are going to save it. Just go ahead and save it to the desktop again. Strange Science U3 Rev B. So we'll save that. And we have just backed up the U3 chip. Now we're going to do the sound ROM. So because this is a different chip, I'm going to have to change the software to read that chip. And this chip is a 27256. So we'll say 27256. And this chip is a Fujitsu chip. And there it is. That is the exact part number that is on the chip. And it is the DIP28, the 28-pin variety. So we'll select that, and we will read out the chip. And so there we go. This chip, you can see, we don't have any ASCII strings that we can directly read, but you can see in the raw data that we do have data. See, if I scroll through it, you can see some characters. But there's our checksum. Let's read it again and make sure that the checksum is the same. And it is the same. I can see it did not change. And so we will save the sound ROM to the computer. Strange Science. This was U7. This was the sound ROM. And I don't think the sound ROM has a particular revision, but I'm just going to call it Rev B. Since it was paired with those Rev B ROMs, I don't want to accidentally mix it up in case newer code is different. So I'm just going to call it U7 Rev B. We'll save it, and the sound ROM has now been backed up. And so if you just had PROMs, the ones that you couldn't erase and reprogram, this is all that you can do. Read out the chips like this and back up their contents to your computer. So that's how you do that. Now I'm going to show you how to flash new code onto these chips. And so this process is only going to work if you have EPROMs as your game ROMs. And you're probably wondering, how do I find new ROM code for my game? Well, you can't just search pinball machine ROMs. You're not going to find anything. What you need to search for is PinMame. That's PINMAME. And what that is software that you can run on your computer to virtualize pinball machines and play them on your computer. And for solid-state machines, you need ROM files in order to do that. So if you just search PinMame ROMs, you will find them pretty easily. So the next step is to reprogram the chips with the newer revision C code. That's the latest revision for Strange Science. And you can see I've removed the labels off of the top of the chips, and it exposes a little clear window above each of the chips where you can actually see the memory die inside each of the chips. And the reason I did that is because you can shine a UVC light into the windows, and that is how you erase the chips. And so I went ahead and erased them using this dedicated EPROM eraser. And this is just some cheap one I bought off Amazon, but it does work. And underneath the little flap here is a big UVC tube light. And so what you do is you put all the chips you want to erase in the drawer, close it, turn it on, and then set the timer to however long you need to erase the chip for. In this case, I set it to 2, which is 20 minutes. And so I just let them sit under that light, and then the timer shut off, and the chips are erased. And I will show that. I'm going to put these back in the programmer and you'll see that they are blank. So now we're back in the software, and I'm going to put one of the 27C128s into the programmer. That was one of the chips that contained either U2 or U3. And I'm going to read it out. You can see it is completely blank. All of the bytes of data in the chip are filled with Fs, and that is a logic level 1, and that is how an EPROM looks when it is completely blank. And you can scroll through the entire contents of the chip and see it is completely blank. But if your software has a blank check function, you can run that instead, and that will directly tell you if your EPROM is blank. See, it says device is blank, so you don't have to scroll through the whole thing to check each individual byte. It just tells you, hey, this chip is blank. Now I'm going to check the other 27C128. It's blank, and I can run the blank function to check that more thoroughly, so it's blank. So that one's been erased. Now I'm going to check the sound ROM just to make sure that it indeed went blank. It's blank. So that little EPROM eraser did the trick. It erased all 3 of the ROMs. And so now it is time to reprogram them with the newer revision C code that I found. And because the sound ROM is currently in the programmer, let's do that first. So what we're going to do is load the sound ROM file. And so here are the files that I found for revision C. The sound ROM file, the U2 revision C, and the U3 revision C files. So we're going to load the sound ROM file in first. And so that is the file loaded into the software. And now we're going to hit program. And so once I click the program button, the new code will be programmed into the sound ROM chip. We got an error. Well, I'm not sure what that was about. What we can do to check and see if it actually did program is load the file again. And I'm going to do the verify function. And what this does is it compares the contents between the file that you loaded and the chip you have in the programmer, and it tells you if there are any differences. So I'm going to hit verify. And yes, we do have a difference. We have multiple differences. We have 71 differences. And so if we go back, we can see where in the chip those differences are because they will be highlighted. And I'm just going to guess toward the bottom. No. Well, I'm going to go ahead and erase this chip again and try it again. And while that's erasing in the background, I am going to put in one of the 27C128 chips and attempt to program that one. So I'm going to change this over to the 27C128. It's a TI, that one. So this one, I'm going to load in the U2 file. So we'll go ahead and browse for the U2 file, load that in, program. Let's see if this one works. All right, this one, we got a successful program. So what we can do now is load the file again, and it's already there. And we'll do the verify function and make sure that the chip matches the file. Verify successful. So that means the file that we loaded into the software is a complete match to what is programmed on the chip. So this is our new U2 revision C ROM. It's ready to go back in the machine. Now I have the other blank chip in the programmer, and we'll just make sure that I do. Always good to double check. So this is the other blank one, and we're going to load the U3 file into the software, and we're going to program this one. And we got a successful program. We'll go ahead and load the file, and once again, verify. Perfect. So the chip has been successfully programmed. We now have our U2 and U3 ROM chips. All right, I think I figured out what the problem was with programming the sound ROM chip. I had to look up the data sheet for that exact chip, and I found out that some of the settings I had down here were wrong. So if you're reprogramming a Fujitsu MBM 27256, the VPP voltage needs to be 12.5 volts, the VCC verify needs to be 5 volts, the VDD write needs to be 6 volts, and the pulse delay needs to be 1,000 microseconds. So with those settings correct, now I should be able to program the chip. I've got the software set to that chip, and we're going to load in the sound ROM file, program, and we should be able to do it this time. And there we go. The sound ROM has now been successfully programmed. So when you're reprogramming your EPROMs, you just need to make sure that your settings are correct, and you may have to look up the data sheet for the exact chip that you have. So my settings were a little bit wrong. It wasn't getting enough voltage to actually program the chip correctly. And so now it's succeeded. We'll go ahead and load the sound file in one more time and verify that we got a good program. And we did. So that is all 3 of the chips for the Strange Science reprogrammed with the latest revision of the Strange Science code. So these chips are now ready to go back in the machine, and we can test them out. And before you put your ROM chips back in your game, it's important to put labels over the erase holes. And that's not just for labeling the chip, but it's also because natural light has the possibility to affect the code in the EPROMs the same way that UV light does. And so putting a label right over that hole protects the contents from being erased accidentally. And so make sure you do that before you put your chips back in. Now let's go ahead and test these out. And with the ROMs put back into the machine, let's go ahead and turn it on and see if it comes to life with the new revision ROMs. And yes, it does. So the Strange Science has now been upgraded to revision C. And we can check that by going into the test menu and using the keypad to go to self-testing. And then we'll check the game ROM ID. There we go, U2 and U3 revision C. So we just updated this machine to the latest version of its ROM code. Or if you want to put it in more layman's terms, we updated the software on this machine to the latest version. And so that concludes my guide for dumping, backing up, and flashing new game code on your pinball machine and arcade game ROM chips. If you have a question about your particular machine, let me know in the comments and I will answer it as best I can. Thanks for watching, and I will see you in my next video.